this auto dibbler project. Got Jared Hoy here. Jared, what's the function of this new device that you've been generating here?
The main purpose for us was to create a commercially viable machine that maintained low horsepower, that could be easily transferred from one tractor to another, and that was basically our goal. When we're all done, we can turn this machine over to a manufacturer and say, here you go, here's a machine that we feel you can mass produce. The object of this machine is to make holes in plastic mulch beds. It can be easily changed from one configuration to another. The old methods used a water wheel, which was kind of crop specific. They only could do one particular crop on that spacing. Ours can be adjusted by just a couple knobs, and the spacing is determined based off of time and distance.
I got Daniel Staley here. He was in charge of, I think, this air consumption model or something. I know that when we run a machine like this, it's got lots of settings. I guess you became a power user at Microsoft Excel in the process. Tell about that air consumption model.
We used the air consumption model to calculate the pressure needed, the amount of pressure each cylinder needed to actually punch the hole but not over punch it, and then to calculate the travel speed on the tractor. And then we also used it to calculate how many RPMs that we could run the compressor, so that when we were hooking it up to the PTO shaft, we knew what size of pulley to get the correct belt size.
Evan Schlegelmilch was in charge of the controller for this auto dibbler. I think there are a lot of electronic things in that box. Maybe you can describe how that all came together.
All right, essentially what we did was we bought a whole new programmable logic controller to basically control all the functions of our auto dibbler. Here you can see we have the main power switch, which turns off the power to the entire piece of machinery. We have a pause switch, which saves your settings that you have it on when you're actually out in the field. Shuts the cylinders down for turning around at end rows. And here you have a switch for each individual cylinder, 1, 2, 3, and 4. And below, we have two potentiometers that control your extension times, which is a form of depth control, and your spacing times. What that allows you to do is decide how far apart. Obviously, you want the holes to be spaced in terms of planting different crops. You can also decide how wide you want to plant these crops as well. Say if you want to have them set wider, you can have on cylinder 1 and 4, or you can have the two middle ones on, or any combination of the 4, basically. Essentially what we did is we took everything off the piece of machinery, moved it up here in this contained box. It's completely detachable from the tractor, so you can store it inside during the winter time in the off-season.
Okay, another challenge of the auto dibbler is the power transmission. I think the previous version we had hydraulics going to pneumatics and then back to drive linear motion. Bill, describe how the power gets from the tractor to actually punch holes here.
Okay, well, standard tractor usually comes with a PTO shaft out of the tractor. In particular, this model has a 540 RPM PTO shaft. From there, we go into a drive shaft, which powers two pulleys, well, one big pulley on the bottom and a smaller pulley on top, roughly 4-to-1 gear ratio. We had to stick within this range for the power to transmit. So it goes through the belts to this top pulley, across the shaft, which is connected straight through to the power or the crankshaft in the compressor, which then generates air and provides the tank air, which provides our cylinders with air.
Daniel, what are we going to call this thing?
The Purdue Holer Maker.
Wait, say that again?
Purdue Holer Maker.